Okay, let's welcome, in this particular case, the last section of Chapter 3. Oh my gosh, it's hard to believe we've gone through 3 chapters. And we're on our halfway mark to the second in-person test. Oh, aren't you excited? Yes! Now, this is going to again continue with compound inequalities, but it's going to be doing a little bit more. It is going to be talking about an intersection and a union. And these are specific symbols that you're going to be working with. They're also going to be using the words and the word or. And then, of course, we've got to have some story problems that I know you're going to be enjoying. But these story problems, I think, are a little easier, but that's just me. Okay? Well, let's continue with compound inequalities. Now, we're going to be talking about an intersection. Now, you see this little U that's upside down? That is the mathematical symbol for intersection. And intersection is what's in common. Okay. That's how I've always thought about it. What's in common? Now, they're going to be giving you some set notation. We have A and we have B. That means what answers in A are in common with the answers in B. Well, if you look at A, B doesn't have a 1. If you look at A and have a 2, B has no 2. But 3 is in both sets. 4 is not in both sets. But 5 is in both sets. So therefore, the set or intersection that both A and B have in common is 3 and 5. Okay? So intersection is that U upside down. And they mean what does A have and B have together? They've got to have something in common. Now, if they don't, well, we know that that's a no solution or an empty set. And we might see a few of those. Okay. Now, notice how different this is. This is a U for union. Okay. Now, the union of two sets is basically joining together, putting together the elements of A or the elements of B, and basically we're putting them both together. Now notice what I do. This union has 1, 2. Now remember, 3 is in common, but I'm only going to write it once. Oops, forgot a number here. Should have put a 4 in here. There should be a 4 in here. Yeah. Forgot my 4. Okay. Then it's 5, 6. Now notice 5 only gets done once. Okay. And then we have 6, 7. Now there's no 8, but I have a 9 and a 10. So in this case, I have my intersection. Okay. Plus everybody else. So I only write 3 and 5 once because they're in both sets. but I write everything else. And I do not repeat my elements. So in this case, I lost the number 4. Okay? So I might fix the PowerPoint before you see it, but 4 is there. Okay? Now, we're going to try this on our own. This is all you're getting. You've got to know what the symbols mean. This is saying intersection. What do the two sets above have in common? Well, they have a 2 and they have a 4. That's all that's there. What's in common? Well, right here, the union is everybody, which is 0, 1. Now, I only write 2 once. 3, 4, 5, 6, and 8. Everybody gets written. Union is putting everybody together. It's like joining a family. You're uniting. Okay? So if you unite, you have more numbers. The intersection is what you have in common. You are uniting, joining together. Okay? Okay. Now, okay. When we talk about the word intersection, in mathematics, we use an and. Now, on your number line, remember interval notation comes from a number line. Writing and drawing your number line correctly is going to give you a correct answer. But if you miss drawing the number line, especially with some of these problems, you may not get it correct. And your answer, this is the beautiful part with an and, it's between the two endpoints, or where the two lines meet. Now, I want to give you an example because it seems that McGraw-Hill wants to do this. Okay, I have 2 lines right here. Okay. This is going to be, oh, let's see here, maybe I can draw a better picture on a new slide. Okay. Okay, I'm going to do it here. Okay. They are going to give you this equation. Okay. This is 0, and we're going to say x is less than or equal to 5. Okay. Well, I'm going to have this graph where 5 is here. I have a closed circle, and I'm going this way. But then they're going to give me this equation. X is greater than or equal to 0. Okay. I have a closed circle here, and I'm going in this direction. They want the and. Right here. This part is my and. between 0 and 5 is my intersection. Instead of putting both equations, the pink and the red, on the same line, they draw two lines. And they want you to merge those two lines together. Where are we in common? We're in common here. This part and this part have nothing to do with my and. So when you see two separate number lines, one on top of the other, and they're using the word and, then you're going to have what's in common. Now, I am going to give you an example. 3 different and examples. Now, I'm going to put them on one number line. But does Pearson? Nah. Or does McGraw-Hill? No. But you're going to have to try and do what I just did. Where does the pink and the red have an area in common when they're separated? Well, we're going to draw this one. This is an example of what we're going to call an and. Now, this is where I'm going to take and use two different colors. Okay. I'm going to draw everything on one number line. Okay. Now, I am going to have a -1, and I'm going in this direction. This is my x greater than -1. I have this 2, which is right here, and it's going to go in the opposite direction. This answer is what's between the two dots. That's the easy part. This is -1. This is +2. This was x less than or equal to 2. Notice my red equation and my black equation I graphed on the same line. My interval notation answer is between the two dots. Now, example 2 and 3 for an and. This is where drawing the interval, drawing the number line gives you the correct, in this particular case, interval notation. Because and, what's in common? That's what you've got to think. What's in common? Well, here's my number line. Okay, I have 0. Huh? Now, I have an equation that is going from -3 all the way this way. This is x greater than -3. But at 1, I'm going in this direction. This is x greater than or equal to 1. Now, notice right here between 0 and 3, I don't have a red line on top of it. My answer is this part of the number line. I'm going from 1 to positive infinity. That yellow area that I just highlighted over here, it's not included in my and because it's all by itself. It only has one area. What's in common between the blue and the red? Well, where it starts to get to be in common is when we hit 1 and go to the right. Now, this is where you're going to have to be real careful with the and. This is considered a no solution, and I'm going to show you the very reason why. I have a closed circle going this way. So this is x greater than or equal to 1. And then I have -1 with a closed circle going this way, which is x greater than or equal to -1. Where is the red and the blue in common? Where is the red and blue lines in common? No place. If it's no place, it's a no solution. And they like to put the little 0 with the line through it. Okay. Common. What's in common? Okay. So if you have something like number 2, it could also go in the opposite direction. But remember, common. That's the and. And let me show you. Okay. Right away. You see this word and. Okay. Okay. The minute you see and, you want what is in common. Okay. You want to have what's in common. That's the catch. You have got to have what's in common. And if you don't have what's in common, you're never going to get your interval notation drawn correctly. Okay. Now, Pearson or McGraw-Hill is not always going to put these on the same number line. They're just going to ask you to write the interval notation. You have to know how to write it. This is 0. This is -5. This is +5. Okay, I am going to draw this in pink, which means I have a closed circle at 4, and I'm going in this direction. Notice the arrow. Then I'm going to take and draw this in red. This is my -1, and I'm going in this direction. Where is my common area? Right here where the black is, between the 2 dots. Where is it in common? Where do they cross? Where does my pink and my red meet? Between the 2 dots. Okay. Now, little different. Okay. I am drawing this one in pink. Here's my -4. And my arrow is saying I'm going in this direction. Now, watch what happens. This is my 1. I'm going in this direction. This area here in black is what I have in common. This area that I just circled in yellow, all I have is the pink part. I don't have the red part crossing it. So interval notation here is very important. It is from 1 out to infinity because of the and. What's in common? The common part is this part of the line, the part that you have to find on your number line. Okay? This is the and. Now, enter the or. Now, the or is the easiest part. You're going in the opposite directions. And then, where does one of the two number lines start? Which means you're reading for interval notation left to right. B is not going to make too much sense until we do it, okay? Because we're still talking compound. Now, let me give you, like I did before, 3 examples here, okay? They all have or. Now, notice my interval notation. Now, this is going to be my pink part. -1, and I'm going this direction. This is going to be -1. I should make sure that I have open circles. This is 1, and I'm going in this direction. And then this one, doing in pink, open, and it goes in this direction. Or is reading from left, which is -infinity, to 1, -1. That's this part. But notice this one has a symbol for union because now from this part, I'm reading to positive infinity. I read left all the way to my first dot. Well, that U is dealing with this space in the middle that doesn't get used. That union says I have a hole. Okay, and notice my pink and my purple go in opposite directions. Now, Number 2, this is what this means, where one of the two start. Well, let me show you what I mean. Okay, this is 0, -2. Okay, this is where I'm starting. And I'm going to make this blue go in this direction. But then I have this. I have 2 going this direction. This is an OR. This is where I start on the left, which is why the interval notation is taking in all of this area that's not in common with what's in common. It's going from -1 all the way out, which means where did my number line first start in blue? It started at -1. Now, this one. Okay. This is the perfect example. Do you see the red and the blue go in opposite directions? Yes, they do have a common part here. For an OR, if they go in opposite directions, it's -infinity to +infinity. Because an OR has to consider everything blue and everything red. It is what is all, or we're uniting the blue and the red. Huh? Now, you might have to think about this a little bit or watch this PowerPoint slide several times, but hopefully I could show you what I mean. Okay, first up, here's my OR. Now watch what happens. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is -5. This is +5. Now, in pink, I'm going to put a dot here, and I'm going in this direction. That's the way the arrow's pointing. But then I have the 2, which is right here, and I'm going in this direction. This is a union. And I'm reading left to right. Well, remember, way over here at the left is -infinity, and I'm going all the way to this dot, which is -2. Now, how do I account for this blank area? I put the U, and then I go 5 all the way out to +infinity. This is my interval notation. I'm reading the number line. If a problem doesn't give you a number line, you've got to draw the number line to read it correctly to get your interval notation. Now, this is where it gets more interesting. Okay, now I've given you some steps to watch out for. Okay, first off, identify the inequality. Is it an and? Is it an or? And understand what an and number line should look like, which means it's got to have something in common, or what an or number line looks like. And there are 3 number line graphs for an and, okay? And there are 3 number line graphs for an or. Remember, those were my examples that I gave you. And what are they talking about? They're talking about these 3 graphs for an and, these 3 graphs for an or. Okay, that's what they're talking about. So you've got to be real familiar with them. Now, where an and or appears in the problem, this is something that I do. I draw a vertical line, and I'll show you what I mean with this step. Then you're going to solve each inequality separately on either side of the vertical line. And here again, graphing each inequality separately on a number line. Check to see that your graph number line matches the and pictures or the or pictures. And then we got to write interval notation. Here we go. Okay, here's my and. I'm drawing my vertical line. And means what is in common. Okay. And means where on my number line are the 2 inequalities in common. Okay, well, now we got to do a little work. Okay, first off, we're going to work with this side. This is my pink side, okay? Now, Q is positive, so I'm dividing by 4, and Q is greater than or equal to -4. This is what I'm going to graph on this wonderful number line. Okay, so this is negative, let's see here. Maybe I should make this a little better. Okay. 1, 2, 3, 4, 5. Okay, this is -4. I am going to put a closed circle, and I'm going to graph it. See how my arrow is pointing away to the right? Now, here comes this part. Subtract 3 from both sides, and I get Q is less than 7 or less than 4. Okay, now this one gets an open circle at 4. But notice it is going to go this way. Huh? Now, common. Where is my common area? It's in here, which means bracket -4, comma 4 here. And 4 on the right side, which is in blue, is an open circle that gets a parentheses. Okay. Let's try this one. Okay, I have an and. Okay. Well, and what's in common? Huh? Well, let's see what's here. I'm going to draw this. Okay, now I'm going to add 10 to both sides. This will give me 6u is greater than 6. Divide by 6. I have a u less than 1. This is my 0. And right here, this is my open circle at 1. And notice I'm going in this direction. Okay. Now, this has a fraction. Remember, we're going to get rid of it. That means I'm multiplying everything by 3. This is going to give me 2 minus 6u is less than 12. Get rid of the fractions. Now I have a negative 6u, and don't forget, I'm subtracting 2. This gives me a positive 10. But be careful here, okay? This is a positive. It's got to be a positive coefficient, which means that this symbol has got to flip. I'm dividing by negative 6. Now this is giving me u negative 5/3. Notice how my symbol flips. This is negative. Well, it's going to be right about here. Negative 5/3. I'm going to have an open circle, and I'm going in this direction. Okay. Now, where's my common part? It's between here. Now, this will give me negative 5/3, comma, 1. And it is parentheses. Okay? Now, seems that I'm missing 2 slides. I don't know why, but I'll get to them in a minute. But right here, okay, this one. Okay. Now, this one, or this is the union. Okay. Well, I'm going to draw a line here. Now, I'm going to add 4 to both sides. This will give me 7n greater than 16, and I'm going to divide by 7. N is greater than 16/7, which is about 2 2/7. So it's going to be right in there someplace. Maybe I should make it closer. Let's put it here. And notice which way the arrow goes. It goes in this direction. This is 16/7. Well, this one. And, we're going to subtract 3 on both sides. Now, notice what I have right here. I have a negative 2n is greater than or equal to positive 6. Okay, when this has a negative coefficient, don't forget that this symbol has got to flip because we're dividing by negative 2. N is less than negative 3, which means I have a closed circle here going here. Now this is the union. You are reading this graph from left to right. Well, what's out here is negative infinity. And we're going all the way to negative 3 with a bracket. How do I indicate I have a gap? There's my U. And this should have been an open circle, okay? This should have been 16/7 to positive infinity. I'm going to infinity out here. Huh? Now, for some reason, I lost 2 slides, and I don't know why, but I am going to see if I can, let's see here. Can I type on this? Let's see here. Okay, insert. I'm going to put this here because for some reason I have lost 2 slides and I don't know why, but you get to see how I put them together. This is going to be 4 plus V, and this is greater than or equal to 3, and I have 1/2 parentheses V plus 3 greater than or equal to 4. Okay, so we're going to get rid of that. Move this up here. Okay, see, I can remake this one pretty good. Yay! Okay, now this is again an and right here. In common. Okay, draw my line here. Subtract 4. This gives me V less than or equal to -1. Okay, here's my -1. I've got a closed circle, and I'm going in this direction. Now, I want to get rid of my 2. which means I'm multiplying this side by 2 and this side by 2, which gives me V plus 3 is greater than or equal to 8. I multiplied the terms by 2. That got rid of my fraction. Now, if I subtract 3, I get V is greater than or equal to -5. Okay. So let's see here. Did I type it right? 4 plus 3, 1/2, V plus 3, oop, +5. Here's my 5. I have a closed circle going in this direction. Okay. Where do the green, where does the green number line and the orange number line meet? Nowhere. This is considered a no solution. And you're going to say, why? They don't meet anywhere. This is the 0 with the bar. They do not meet. This little word and is saying what's in common. Well, the green and the orange don't meet. So therefore, can I have a solution for an and? No. Now, again, this was a problem. For some reason, I lost 2 slides, and I'm going to have to put this back. So this is 3c plus 11 is greater than 2, or a negative 4c is greater than -8. Okay. Now, notice the word in the middle is or, okay? Or represents the union. Okay. Subtract 11 from both sides. I get 3c is greater than -9. Divide by 3. C is greater than -3. Here's -3. I have an open circle, and I'm going in this direction. Why am I going in that direction? Because which day does the arrow point? Now be careful with this one. This is going to affect that symbol. I'm going to divide by -4. This gives me a positive c is less than 2. Well, I'm going to have an open circle, and I'm going in this direction. Well, this is a union. In and or compound inequality. When the green and the hot pink go in opposite directions and they cross, you have only one answer. And that answer is negative infinity to positive infinity. Union, you're reading left to right. They cross, but because it's an or, you only have one answer, negative infinity to positive infinity. And with that said, yay, we got that done. Okay. Okay. And last but not least is my story problem. Okay, now, when you do a story problem like this, what you want is to try and use a highlighter, or you need to basically understand what it's saying. Now, in this case, it is saying you have this table. List the elements of the set. Okay. And this is where you have to understand that this is set A, this is set B. Okay. And we're looking for either the union of A and B or the intersection of A and B. Now, list the elements of the set that satisfies the given information. The set of teams. So that means the teams are what we're going to be giving as answers. With more than 30 playoff, and it should say appearances, and I don't know why it doesn't say that. Okay, look at playoff appearances. Where do we have more than 30? Okay, more than 30. Well, first off, we have the Boston Celtics. 29 is not more than 30. Neither is 18. The Detroit Pistons, the Lakers, and the Knicks. And, okay, and more than 10 championships. Well, who has more than 10 championships? Well, the Celtics, the Lakers. And what's in common between the circles and the checks? Well, that means that this is going to give us the Boston Celtics, comma, Los Angeles Lakers. That is our answer. What circles have checks? And means common. So our answer is the Bolton Celtics and the Los Angeles, if I can spell right, Lakers. Okay, same table. Now, list the elements of the set that given these conditions. The set of teams between, okay, between 20 and 30 appearances. Between. Well, that's my Chicago Bulls. Now, Detroit Pistons had 32. They're not between. So all I have is the Chicago Bulls right here. Or fewer than 5 championships. Well, the Cleveland Cavaliers have fewer, 3, 4. This is an OR. Now, an OR is going to put the circle and the checks together, which means that it's the Chicago Bulls, the Cleveland, if I can spell, Cleveland Cavaliers, Detroit Pistons, New York Knicks. Or means in this set, give me the circles and the checks together. Okay. This now ends chapter 3. You have a chapter 3 review that will be coming up. Okay. And you should have a good time with the ands and the ors. There I am. Yay! Have a good time with chapter 3.